All right, let's get to it. Hope you all had a good and productive weekend. Can you all see my screen? Slash here, yeah. If you're thumbs upping, that means you can definitely hear me. All right. Today we're going to be talking about inheritance, and let me make this a little bigger. For now, I'm going to shrink this out a little bit and knock my notes. So inheritance is a big kind of concept in object-oriented programming in Ruby specifically, and we're going to talk about like how we're going to use inheritance, how you can use inheritance, how we already have been using inheritance. And so I think that when without any kind of context, when we think about the word inheritance, I think that we often think about like something passing from one to another. Like me personally, I think like the idea is like someone inherits something from a dead relative, right? That's when a person gets like all the dead person's stuff. Hopefully it's not stuff, hopefully it's just money. But the idea of like something that belongs to one previous thing that gets passed down. And so this idea kind of manifests itself, like we've been using this already, right? Like, so in your tests, you've been using methods such as add a reader and assert equal, like in your testing. And the idea is like, well, where do these come from? Like, like they just kind of magically appeared. Like when we think about it, like where does puts come from? Like we inherit these things down. And so the point I want to make is that in Ruby, capital R, inheritance is one way that we can use code defined in one class in multiple classes. And so an example of this is that kind of assert equal, right? We make all these different test classes and we're using them everywhere, but we all get them from somewhere, right? And the idea here is that the benefit of inheritance is reduction in patient. I can't talk, type, and think at the same time. Cool. And so kind of like the big picture here is that we use inheritance in a way to kind of like shrink our code base to avoid repetition. If we have a bit of code that is shared across many classes, inheritance is one, and there are other techniques that we can use to kind of pull it out and consolidate our code, right? Oops. And so Sandi Metz defines inheritance as a mechanism for automatic message delegation. It defines a forwarding path for not understood messages. Also true. And so let me do this, make a new file, Ruby. When we do something like this, right, this is very similar to code you've already seen. We require main-test pride and main-test auto run that, but essentially this is something we've seen. And the point I want to talk about the most is this bit right here. The less than sign here means I want you to inherit the characteristics and behavior from the test class of the main test module. And what we're doing here is that we are taking all of the methods that are inside the test class of the main test module, and we are bringing it into our node test class. We're going to talk about modules a little bit later, but so we don't need to kind of know about that. When we're inheriting in Ruby, and I'll copy and paste these notes to you at the end of the class. There are a couple things that we need to remember. Objects modeled using inheritance must demonstrate generalization, specialization relationship. We're going to get into the nitty gritty of how this works, but just to kind of like give you an example of what a generalization specialization relationship looks like is a dog and a beagle. Dog is the generalization part. Beagle is the specialization part. Cat, Scottish fold. A cat is like the overarching big thing. Scottish fold is a certain kind of cat. I like to think the way I like kind of define this is I use the words is a, right? So it's like a beagle is a dog, a Scottish fold is a cat or is a kind of a cat. That helps me kind of like really define in my mind what the relationship between the two, which is the general, which is the specialization. Cool. Next, when a class inherits from another class, it receives access to all of the instance variables from that class. That's pretty straightforward. We're going to get into that and demonstrate that specifically. The inheriting, is that spelled right? It looks weird, but I think it's spelled right. Class is called the child or the subclass. So the dog example, beagle is the subclass. The class being inherited from is called the parent or the superclass. So again, in that example, dogs is a superclass. Class can only inherit from one parent. For example, a beagle can only inherit from dog. It can't inherit from cat. That doesn't make any sense. Why this exists, we are going to talk about in the future, but this feature is known as single inheritance. The chain of parents, and parents is called ancestors. So to kind of demonstrate this, we talked beagle, dog, right? So what if dog inherited from mammal, right? So, and mammal inherited from things that are alive. I don't know what goes on top of mammal. But this whole idea is that there's this chain that we follow up, and this entire chain is called a thing's ancestors. Any number of classes can inherit from a single superclass. What this means is that although we can only inherit one going up, we can opposite of inherit multiple times going down. For example, to kind of demonstrate this, we could have a beagle class that inherits from dog. We can also have a golden retriever class that inherits from dog. We can have as many children as we want, but only one parent. Cool. So, like I said, we want like the using the words is really kind of helps clear things up in my mind, because it's like it's very makes it very clear about this relationship, right? The problem that inheritance solves is that highly related types share common but they still can have differences. And so kind of like if we were to kind of like use this example to go talk about code, excuse me, we use inheritance to kind of reduce the amount of code we have to write that potential different classes can share. So let's go back to the, let's say, golden retriever, beagle dog example, right? If we were to make a method called bark, this bark method would be something that goes into the dog class, because presumably, let's just, for our purposes, all dogs bark, right? So that method for barking would go into dog. However, let's say we have a method called howl for dogs that howl. We could say that this howl method, not all dogs howl, so this howl method could go under beagle and not golden retriever and dog, and only beagles can howl. Right? What do golden retrievers do? No, dogs. I don't know what golden retrievers do. We have a retrieve method, right? And we could put this this retrieve method under the golden retriever, because only the golden retriever retrieves, not all dogs retrieve, and beagles certainly don't retrieve. So like behaviors and attributes that all these things share go in the superclass, or specific differing behaviors and attributes, they would go under the child class. Questions at this point? Cool, Max?
Yeah, just a question on kind of that dog metaphor.
Yeah.
So if you have multiple dogs that howl and multiple dogs that don't,
yeah,
would you set up a subclass like howling dogs, and they would inherit from there?
Personally, I would use a different tool that we'll cover later on. I'll probably use a module to bring that in. I personally, I see inheritance as more of a structural organization tool that also has the benefit of allowing us to reduce the code we write. I think the fact that we have to think of things as that using that is a relationship helps me use this more as primarily an organizational tool. Mike?
So what other examples have we seen this in the works thus far? So mini test. Do you have any other like explicit examples like that we can relate this to?
Not that you've seen. Anytime you see that less than sign is where you would is exactly where you would have used it in Module 1.
What about other things that we have used in Mod 1 that would
be I'm trying to run through the list. The idea is that every single bit of code you used so far has come from somewhere, right? And the idea here is that Ruby uses inheritance in the background to give you access to things that you don't have, right? And I think we're going to demonstrate that in a little bit. Cool. All right. So what we're going to do is that we're going to type out. So we're going to show you some code, and we're going to work through some stuff. I'm going to close this because we don't need this no more. Don't save. I'm going to save that. I'm going to touch employ RB. You can follow along if you'd like and type this along. I would recommend against it because all this code is in the lesson plan. So I would much rather that you kind of pay attention to what I'm doing and then copy paste that later as we go on. Oh, I see some more hands. Let's start with Sydney.
Sorry, and I think I'm confusing this with the module as well. So like inheritance, you're just kind of like offloading some of the responsibility from the parent class? Or?
I would not say offloading is the right term. You're bringing whatever is inside the parent class into the subclass.
I guess I don't understand why you need to do that, or why you would want to do that. If they're supposed to be single responsibility, and that class is, sorry,
No. It's a great question. We would do that because we would want to reduce repetition. We want to dry out our code a little bit. So like, let's say if we had 5 different like species of dog classes, right? We would pull like a bark out of that. So we don't have 5 different bark methods in 5 different classes. It would just be in one place that all the things now all inherit from. It's a tool to dry up our code.
Okay, so when I'm doing another class and I'm starting to need the same functionality that I have in another class, that's when I want that class to inherit from that class.
Yeah, if it's a situation where that kind of makes sense, where like where we like I kind of talked about this up here, this generalization specialization relationship, right? Like it has to have this like generalization specialization relationship. Just because 2 things share the same kind of code, like have something that does the same, doesn't mean they have this relationship. And a module, which we're going to talk about later, may be a better tool for that job.
Okay, that makes sense.
Joseph?
Yeah, I'm a little confused about like, so if we're inheriting from a built-in class from Ruby, like we would use a require method for some, like require CSV.
That is not inheriting.
That is not inheriting.
No.
Okay.
Yeah, that is simply just making the code available to us. What we're doing here is we're adding behavior and we're adding attributes.
Okay. All right. That makes more sense.
Cool. All right. So we have this employee here. I'm just going to copy and paste some code. Right. And we have this total compensation. Like every employee is going to have a total compensation, and they are going to have a base salary plus a bonus. Right. And then what I'm going to do is that I'm going to make a, oops. I have a CEO object. Paste that. Cool. And so, hold on. I'm gonna do this. So in this runner file, and this runner file is going to instantiate a new CEO. Their base salary is going to be 15. Their bonus is going to be 20. And we're going to call the total compensation method on the CEO object on Ally. And so what we're doing here is CEO object takes the base salary and the bonus, and it's going to save it there. And it's going to inherit from the employee object. And when I run it, oh, I got to require the CEO object. My mistake. Cool. We see here it's 35. And this is what inheritance does for us. Nowhere in the CEO object, the CEO class definition we have we defined a method called total compensation. But we have defined it in our employee object, which CEO inherits from. And because it does have access and like it does have access to base salary and bonus because it isn't part of it, and that's stored as instance variables. We have an adder reader here. Karen.
So I just want to see if I'm getting this like right. Would this be inheritance? Would that be a good way of making objects interact? Like
depends on the situation.
Okay.
I would not use it again. Like inheritance should be as a tool for organization and for drawing out your code, and to kind of like give structure to your code, and less as a way to make things interact with each other.
Okay.
Max?
Yeah, how would you test the employee file? How would you run tests on that? Because it doesn't actually have base salary and bonus in it.
Yeah, you would test it through CEO.
Okay.
Other questions? Cool. Exciting. Sam?
Let's say the superclass or the parent class had a definitialize, and so did the subclass.
We'll talk about that in a little bit.
Okay.
We're gonna get there. And we'll circle back with you to make sure we answer your question. Joseph?
Yeah, I'm sorry to go back to Max's question. What would that look like to test from the actual, like to test employee from?
Yeah. So essentially, you just test out that the total compensation method returns 35.
Okay.
Yep.
Okay. Cool.
Yeah. Don't need to apologize. It's a good question. Cool. And so we can still define methods in our CEO class, just like any other class. We can still do this. Def, greet, whoops. Right, this works just as a class. Like this works pretty fine. It's just that we have access to everything that has been defined in employee. You see that hello there? Cool. All right. So what I'd like you to do is I'm going to break. Actually, let us take a Pomodoro break. Let's be back at 9:29. And we're going to give you some opportunity to practice this on your own. Let's be back at 9:29. Let's resume recording. So what we're going to do now is that I'm going to put you into groups. And what you'll be doing is you'll be taking the code written. Again, this is all in the lesson plan, so you can copy and paste stuff. And what you're going to do is that with either one or two new best friends, you'll be creating a sales manager class that inherits from employee. It takes base salary and estimated annual sales as arguments when you initialize. You're going to create a bonus on sales manager that returns 10% of estimated annual sales. And you're going to create a new sales manager in your runner file and print the total compensation to the terminal. So what I'm going to do is I'm going to put this in your Slack channel. And I'm going to send you to groups. We're going to take about 10 minutes to do this. And we will... I should probably post the lesson plan. Link to it in your channel too, just so you have it. Here you go. We'll have 10 minutes in the group, so we'll come back and we'll go over it. There you go. All right, we're all back. So let us take a look at what we're supposed to do here. Create a sale. Let's just go through the steps one by one. Create a sales manager class that inherits from employee. Takes base salary and estimated annual sales as arguments when you initialize. Fine. I created the files already just because like that's what we do. So one, create a sales manager class that inherits from employee. So we use the lesson sign. Cool. And it's going to take base salary and estimated annual sales as arguments. So def initialize salary estimated sales salary sales Oops. Salary. Oops. Cool. All right. So let's just make sure I did that right. Creates a sale manager. Check. Inherits from employee. Check. Takes base salary and estimated annual sales arguments initialized. Check. Create a bonus method on Saleskeeper. Saleskeeper. Sales. What the hell is a Saleskeeper? Sales manager that returns 10% of estimated annual sales. So that's going to be estimated annual sales times 0.1. Cool. And create a new sales manager on a runner file and print the total compensation to terminal. I deleted what we had before. So we do meg equals sales manager.new, and we're going to pass it base salary 10, estimated annual sales 100. So that, I don't know what the math's going to be, but it's going to come out even. Meg.total compensation. Cool. Let me save this over here. And we're going to run the runner. Oops. Doesn't like the dot. Let's put that in parens. Oh my gosh. Times. Nope. Times 0.1. What am I doing wrong? 0.1. Initialize constant employee. Yep. Because I have not, you can't require something. I mean, you can't inherit from something you don't know about. There. Cool. I need to put it. And 20.0, does that? Yeah. Yeah, that math checks out. Right? Yeah. I think it matches. Yeah, I'm pretty sure that checks out. Questions? Notice here that, like, I think I want to draw attention to the fact that bonus here is still accessible because, like, bonus is being called that and it looks a bonus. Like, the difference between this and what we did originally was that bonus is an instance variable, but also it's referring to the method which Adderita gives us. So, Mike?
You just answered my question there.
Okay.
But I also have another one.
Yeah.
So every time a subclass is initializes from the superclass, does the superclass get initialized as well?
That's a really good question. I don't think that so the things that you're not initializing an employee class, right? So like if I were to do, let's take this here, right? If I do puts meg.class, what do we think I'm going to get?
The sales manager.
Right, sales manager. We're not initializing. We're not instantiating an employee class. We are instantiating in this case, sales manager. In the previous case, CEO. Right, like employee is not being instantiated. It serves as contained for code that we are now going to bring in to our subclass.
What if our employee class held a truckload of data, and then the sales manager inherited from the employee class access to that data. Every time I instantiated a new sales manager, would there be like bottlenecks having to like get access to that data?
It depends on what you're putting in there and how you're putting it in there. But the idea is that if you are storing it in, like, say, instance variables, right? Like, that employee who's not be where you would store that, and like the data has to come in from somewhere, right? And that would come in through the sales manager, right? Because if you're creating something with data, you're instantiating the sales manager will get that stuff. You would have to interface through the sales manager, not the employee. The employee is just this holding place for behaviors.
Right. Okay, cool. Thanks.
Yeah. Well, we're going to go a little further, and we're going to dig into other stuff the employee does in a little second. So I think that what you're reaching at is the same thing Sam was reaching at. And like when we get there, I think it'll be a little more clear.
Okay, thanks.
Sydney?
So because the employee knows the base salary, sales manager doesn't need to know it, but
sales manager does, because you're passing it through when you initialize.
Okay, yes, but can I also pass in a new value when I call like sales manager.new? Can I override what CEO
you are though?
knows?
Well, CEO is not involved here at all.
Or I'm sorry, employee, what employee knows. Can I override that?
I don't understand. I guess I don't see like why you would override it, because when you create sales manager, you're just giving it the base salary right here. So like, I guess my question is, to what end would employee like want to change what the base salary is?
Oh. So hold on.
Yeah.
Just confused myself. Because the new information is the estimated annual sales.
Yeah.
Right. So that's what I was passing.
Quote unquote new.
The
estimated annual sales is something that is unique to sales manager that CEO does not have.
Okay. So when I pass in my argument, I thought that's what I was defining.
You're defining base salary and estimated annual sales, right? Employee only knows about base salary.
Correct.
It doesn't know about bonus. So therefore, in sales manager, we define bonus as this method. In CEO, we've defined bonus as stored in an instance variable.
Correct.
So this is that kind of differentiation between the specialized classes.
Okay, I'm gonna have to look at this a little longer because my brain is just messing it up.
Like just like the idea is that CEO and sales manager drive their bonuses differently, right? CEO, it is passed in. Sales manager, it is calculated. The employee doesn't really care. All it's looking for is that it has a method called bonus to call upon, and it does in both the CEO and the sales manager. Like essentially, like what we've done here in CEO. Let me take away this Greek here. Right. So this adder reader, what adder reader does for us is it creates a method that does bonus right. That's what this does for us. So essentially, employee here is calling this bonus here and this bonus here.
So, but it's pulling that bonus that's being passed in the argument to the object Ali, correct? That value is coming from that object?
Yeah.
Okay. And then it doesn't need to redefine that value for sales manager because it's inheriting.
it's not redefining it. The thing is that like CEO and sales, Ali and Meg are completely separate objects.
Right.
They don't live together. So like employee, a way to think about like what's happening with inheritance is essentially when we inherit from employee, what we're essentially doing is we're copying and pasting whatever is in there.
Mhm.
Nope. Down below. Right? So when this is trying to find bonus, let's take this away. When this is trying to find bonus, it's going to pull this bonus.
And that's why we're not getting wrong number arguments error.
Why
When
would we be getting wrong number of arguments? Like when Ali was
Because
we had Ali,
sales manager is expecting the base salary and the estimated annual sales.
right? And this, yeah, but that's sales manager, not CEO.
Right, but when we're creating the object sales manager, we're
Uh-huh.
only passing it one argument.
No, we're not. We're passing in two. We're passing in the base salary and estimated annual sales.
Not literally. Like there's only one argument in there.
No,
Right.
no, 10 and 100, not 10,100.
Oh my gosh. Okay. I was like, where is this other argument? Okay, got you.
Okay, cool.
Ignore me. I was sitting
okay.
here like, it's only 10,100. Okay, got you.
It's okay. Yeah, I'm glad we figured that out. It's cool. That happens. Cool. Does that answer your question? Are we good? All right. Fantastic. James.
Yeah, I'm just curious. How would you unit test the employee class? If you're not,
so we wouldn't. We would just test the children classes.
Okay. Thank you.
Karen.
Okay, so inheritance is this thing that we can use to help us refactor our code, right?
Yes, it is a technique used to refactor code.
Okay, so like in our project, if we're creating a class for every single group of like methods, we would use inheritance in our like stat tracker class, I think it's called.
You can.
Okay.
So the thing is that like inheritance is one technique to achieve this goal. It is not the only technique, and it may not be the best technique.
But it is an option. It's just like
it is an option.
Okay.
Yes.
Okay, and it helps us like, so the tests that we write for each class, inheritance is going to help us like maintain like integrity for our tests.
No, inheritance is just a place, just a tool to help you dry up your code and give you a little more structure and organization to your code.
Right, but our tests should still like run okay, right? Okay.
If your tests are written properly, yeah.
Okay, cool.
All right, Ben?
Yeah, so let's say you had in your employee class, let's say you had a bonus instance variable, but you still like, they still needed to have for the different sales manager and CEO, they still needed to have those separate bonus things. How does it like, is there like an order of precedence to where it grabs bonus from?
Yeah, yes, it's just going to be like when you think back to your scope lesson, that's the same process that it takes.
Okay, cool.
All right. Joseph?
Yeah, my question is similar to Ben's. If bonus was defined differently elsewhere, like what would happen at that point? Does it take? Would it just error out, or?
Yeah, it depends on where. So the idea here is that like when you are looking for something, like let's say like the sales manager has. Oh, why did I delete that? Sales manager has this bonus method. It's gonna look here before it looks to the employee. So I think we're gonna see an example of that a little bit.
Okay.
Of how that kind of works and how we can override things.
Cool.
Yeah. Max?
Yeah, so let's say you had a method in employee that was like, that called time off. And you don't have a time off in your sales manager class.
Yeah.
Is that going to error?
Yeah.
Okay.
I mean, wait a minute. So if a method in employee calls a method is
right. And you would never call that method, but just the fact that it's calling something that doesn't exist.
Yeah. So what's going to happen is that it's going to look upwards for time off method, and like perhaps whatever that, if employee were to inherit from something else, let's say if employee were to inherit from user, it would go up to user and look.
Okay. And if there was nothing there,
it would eventually, yeah. Mm-hmm.
Gotcha.
Cool. All right. Awesome. Good questions. Let's go ahead and take a break. Let's be back at 10:04. All right, it's 10:04. Let's get back at it. The next thing I want to talk about is this keyword called super. And essentially what super does is it calls a method from the super class that has the same name. So example, if you call super in the initialize method of CEO, we're going to call the initialize method of employee. And that's kind of confusing. It's really kind of super important to think of super meaning call the parents method. So the example we're going to talk about is that we want every employee to have a name and ID. So what we're going to do is that we're going to modify employee to take a name and ID. Oops. That is not helpful. Cool. I'm going to get rid of one for now. Right, so we create an initialize method for employee, and now we want to kind of change our, we want to update our CEO to take name ID as well. So instead of like, the idea is that we don't want to like just put name and ID in here, right? So what we can do here is that we do base salary bonus name ID. And down here, we write super name ID. So in our runner file, we would have something like Ali equals CEO dot new. We're going to pass in, oops. Salary is 10, bonus is 10, name is going to be Ali, and ID is going to be 1, their CEO. And this will work. So what's happening here is that when we initialize, let me copy and paste this. I'm just going to put this down here so we can see it all at the same time. And let me change this to a 2 so it's a little more clear that these are separate things. What we're doing here is that we want every single employee to have a name and an ID. So we don't want to have this definition of the name ID in the CEO, in the sales manager, and every single kind of employee object that we can think of. So what we can do here is that in here, in sales manager, we are going to set the base salary and the bonus. These are things that are kind of like set here. And then we're going to call super and pass it the name and ID. Calling super is going to look, okay, super is called. What method am I in? I am in initialize. Okay, so I'm now going to run initialize for my parent class. I want to pass them in these 2 things. And so now this CEO object now has a base salary, bonus, name, and ID. And this kind of slims it down because like we don't have to have name and ID in every single sub-employee subclass there. We move that all the way up to employee. Questions? Cool. I want to note that there are 3 formats to super. Super, arg1, arg2. This calls the superclass method with argument 1 and argument 2 specifically. As we've seen here, we are passing through the employees initialize just the name and ID. That is our first kind of format. We have, we have super like this. And so when we just call super on its own with nothing else afterwards, it sends everything. So if we were to change this and just have super like this, I'm going to comment that out. The initialize in the employee class would get base salary, get passed with base salary, bonus, name, and ID. Super with like just by itself just sends everything. Everything that came into this initialize will come into that other initialize. And finally, the last one is going to be super with empty parens. This will call the parents method with no arguments. This is the pretty much the only time in Ruby that you'll be using parens with nothing inside them. Max?
Yeah, I think I understand how it works if you're like sending from initialize to your parent initialize. What would that look like for a different method?
Yeah, so let's say why did I put that in quotes? That makes no sense. So if we did something like this, it would just run this. It would just return high. We could do something like, I guess, a more real world-ish kind of use. Right, like that. Honestly, like I can't think of any like uses that would off the top of my head that you would use for a non-initialized case right now, because essentially like I would like instead of doing this, I would just kind of like leave that off and they'll still work because you're inheriting from this class.
So is it like if you had the base functionality of greeting, but every time the sales manager said greeting, they said like something extra? Would that be a reason?
You wouldn't use super in that case because like you would just create a different greet method for the sales manager and use that instead.
Okay.
Like that, there are probably uses where you use super for a non-initialized method, but I can't think of any off the top of my head, and I doubt that you'll probably use it. It'll be like this weird thing that you have to do like once, and so you'll use it. But like I think that like using super in this regard with the initialize, let me take this out before I get in trouble and wonder why things don't work. This is probably going to be your 99% of the time you'll use super in this way to kind of like refactor out your initialize method. Cool. Adam?
Yeah, I'm trying to think through. I know you mentioned it's hard to find examples, but when we would use super with no arguments. When we would use super with no parentheses, we would use super with empty parentheses.
So I would. If my employee method were to let's say that this method, send welcome email, hits some other method somewhere else that sends a welcome email to like the employee, right? Then I would probably do super with all the arguments and pass student welcome email, base salary, and bonus, right? Because you figure the welcome email is going to have that information. Does that kind of make sense? That is one example of when I could use super with all the arguments being sent through.
That one makes sense. I don't quite understand when we'd have no arguments. I don't quite understand what that does.
It would just run initialize. Like we could, what if we did a puts created new employee. Let's say we didn't have that name and ID. Let's just pretend that we don't have the name and ID and you just want something printed out the screen. You could have that done. So that would just print out to the screen. Or you could have like, and instead of just puts creating employee, you had some other process that needs to be run, some kind of maintenance outside of this that you want to run. That's when I would use that.
Okay, thank you.
Like you just need that, like you just need something to fire off and it doesn't really matter what it is. That's when I would like not send it when I just want to run, not really care what happens. Cool. Let me get this back to the way it was. Liam?
When you had the like greet method in the employee and then also in the CEO, would that like cause any issues if you had like a parent method and a child method with the same name? Could you like give one additional?
Yeah, no, because what happens is that the CEO, right? If we run a greet method and there is a greet method in the CEO object, it's going to run that greet method. It's not going to go up the chain and look.
Okay.
Right. So there's like the lower method will always override the upper method. And we're going to show you a little example of that in a little bit, I think.
Gotcha. So you couldn't really even make a CEO method with the same name because it would just, the employee supersede it.
You can because the CEO supersedes.
Oh, okay.
Right. The child will always go. The idea here is that we are creating this, what's called a lookup chain. When when you are, so let's take a look at this, right? Let's say the CEO is looking for bonus and total compensation. If I had this in here, this bonus would take the 100, right? Because it is a local variable inside my method scope. Now, if like, let's say the way before it was before, I don't have this in here, it finds no local variable with the name of bonus inside total compensation. So the next step is that it's going to look for what sibling methods do I have in my class with the name bonus. And we have that method here with bonus.
So the reason you would do that is if you wanted to add additional functionality for just the CEO class.
We're gonna show you some more detailed examples of that.
Okay.
Right.
Cool.
And so the idea here is that if we don't have a bonus method in our CEO class, it's now going to look into employee. It's going to look for bonus there. And then it's going to keep going till the end. As soon as it finds it, it stops looking and is done. It's kind of like that example I use, like when you lose your keys and you start looking for your keys. When you find your keys, you stop looking. You don't keep looking for your keys after you find them, right? Or anything else. Like, that makes no sense. So as soon as CEO finds a thing, it's going to stop and use that copy. It does not continue to look for other things.
Gotcha. Okay, that makes sense.
Yep. Cool. All right. Let me make sure my code is in a good spot. Employee looks fine. CEO looks fine. Let me take this away because that doesn't really belong in there. Get rid of this white space. I think we're good. Employee looks good. Excellent. And so I want to talk next about this idea of overriding. In Ruby, what we do is that we override methods from our parent class by defining it in our child class, right? And the reason why we do this is that we've seen so far that in our generalization, generalized, specialized kind of model of thinking, the specialized, there are differences between them. And there are potentially differences to the general rule. The example in the lesson plan is that a mammal may have a class called lay eggs that would return false because most mammals do not lay eggs. And this is like a new fact for me. However, the platypus is a mammal that lays eggs. I thought the platypus was a bird, but sure. So like the idea is that we would have a method where if we were modeling this all out, the platypus class would have a method called lays eggs that returns true, right? So what I'm going to do is I'm going to make an intern class. Okay, so what I'm just going to copy and paste this. So we're going to model this intern object at our company that we're running. And we're going to say that interns are paid an hourly wage, but not a bonus. Like interns don't get bonus. They just do things that we tell them to do. They are not worthy of a bonus. And so they're compensated by defining the total compensation method here. We are essentially overriding the compensation method here. So I'm going to go to my runner. Let us make Tim our new intern. If we look at the intern, is going to have an hourly rate of 2. Their name is going to be Tim, and their ID is going to be whatever, right? And I'm going to do Tim.total compensation. Is 2,000 a lot of hours? 50 days, 50 weeks, like, yeah, so let's call it a year's worth, right? I don't want to do puts because we need to put that to the screen. So theoretically, 2 times 2,000 is 4,000. This should print out to the screen. Got to require intern. This should print out to the screen 4,000. Yeah, that's right. So as we see here, the whole process of what happens is that we're instantiating an intern that inherits our employee. Cool. Let's run here. We are passing it 2, which gets set to hourly rate. Check. Name, Tim. Cool. ID, that number. And what happens is that we super and we pass into the name ID. So over here, we are setting the name to Tim, the ID to that number. And then we run total compensation on the Tim intern object. Total compensation, this is defined in the employee method, and that returns the hourly rate of 2 times 2,000, which is the number of hours, giving us 4,000. It does not run to the employee method because it finds it right here. This method has overridden what we've defined in the employee method. Cool. Karen?
So like overriding relies on this like lookup chain, which is a hierarchy of like what is that hierarchy exactly?
The hierarchy is kind of like is like this idea of scope, in that when we look for something in a class, we call something, it tries to find it. If it doesn't find it, it's going to go to the next level. So what we're doing here is like we are, let's go back to sales manager. When we run, let's say we print out total compensation on the sales manager object, sales manager is going to be like, okay, so I do not have a method called total compensation. But however, my parent is employee. Hey, employee, do you have a total compensation method? The employee method is like, yes, I do. I'm going to run that method. If it didn't, it would then go up to the next thing up in the chain and so forth until it either found it or we end up not finding it anymore. And then it tells us that we have that no method error.
So first it goes method, then class, then parent, and then any other ancestors. Yep. Okay.
It goes up the chain. Cool. Max?
Yeah, so just on that logic, does that mean in Ruby, like you could define a method that is puts, and that would override the Ruby method puts? Okay.
You could. That's a process called monkey patching. You should never do that. Just like it's a bad idea. Overriding built-in methods is just a bad time. Because what happens is that someone's going to try to use that method expecting it to work the way it does in Ruby, and then it doesn't, and then you're like, what the hell's happening? Cool. We can also combine super and overriding. So what we're going to do is that this is a great company that we work for, Ruby Corp, and we are going to give our employees benefits, right? So I want to make a benefits method in employee that's a sick leave. And for the CEO, what we can do is that we can override with super. And so, you know, this is the exact example that we were talking about earlier that I couldn't think of. So what we do, what's essentially happening here is that super is calling the benefits method in the parent class and adding health insurance to it. So if I go, let's take this away. Let's do a puts alley dot benefits. And actually, let's do this. Puts. Let's make a. What was sales manager? What did sales manager want? Sales manager wanted. Oh, I need to retrofit this. Cool. Sales manager base salary is 5. Estimated annual sales 100. Meg 3. Puts meg dot benefits. Cool. Save. Run it. this so we can see it more clearly. We can see that Meg, being a sales manager, gets sick leave. Allie, being the CEO, gets sick leave and health insurance. And that is because we have taken, ooh, why did you do that? We've taken the benefits and added on to them. Any questions? Cool. So what we're going to do is, what was the last time we took a break? Is it time for a break? Oh, 04. Yeah, let's take another break. Let's be back at 10:35. You'll get some practice and we will return. 10:35. All right. So, what we're gonna do is, why is it weird? I'm gonna post a little task for you into your Slack channel, and we'll take 10 minutes to do this. As soon as I can find your breakout rooms. Cool. Off you go. All right, that looks like, oh, no. Yep, video. That looks like everyone's back. Fantastic. So I just, did this real quick. As a answer to your thing, like the try it was override a method and or use super so that when you call total compensation on CEO, it adds $1 to their base salary before returning the total compensation. So essentially, I added $1 to the base salary, and it's like, hey, employee, do your math, do your magic. Cool. Important things as we kind of wrap this up. Important things to note. Words of caution, if you will. Like today, what we did is that we created 2 subclasses for employee superclass. We did CEO, three subclasses: CEO, intern, sales manager. Important things to note, like you may think, I think that people often like, oh, inheritance, I'm going to use it for everything. The idea here is that like we are creating this hierarchy in terms in like, and the thing is you may not need it. The idea is that sometimes like if you just have a dog and a husky, like is that a point where you need to make a super class? And probably like if it's just a dog and a husky, that's something I can live with. You may start introducing more overhead and more hierarchy than you actually need. Like the whole Yagni idea. Nope. You ain't gonna need it. The idea is that we have this tendency to kind of over-engineer things when we don't need to. You don't know any less about a problem as you do right now. So like the idea of like thinking about inheritance as a solution to future problems is just not like, don't do it because you don't know what's going to be needed. Especially in the idea is that it's easier to promote abstract parts of the code up to a superclass than it is to move down from like a superclass down to a subclass. So the idea is that it is much easier to create a super class when you have a bunch of other classes. However, if you have a super class and you gotta move stuff, that is a much more difficult thing. Adam?
Yeah, I saw your answer here at base salary plus one super.
Yep.
When I run
sorry.
that,
plus equals one.
Oh, plus equals. Okay, thank you.
Mistake. Oh, yeah, that was my mistake. Still bad at typing. Still bad at typing. Cool. The next big point is that while subclasses should rely on functionality from the parent class, a parent class should not use methods that are not defined within the parent class. The example we're going to use here is that we have our employee class here on the side, right? And employee class relies on base salary and bonus. Later on, if we create like a manager subclass, the parent class is pretty much imposing the fact that we need to have a base salary and bonus. So that means base salary and bonus have to be defined within the subclass that the parent uses. And like in the lesson plan, there is a example of how we can kind of like document it in that way. Cool. That is all I have on inheritance. Y'all are set. You have project work time for the rest of the morning and the first part of the afternoon. You have PD at 3. Watch out during lunch hour as inheritance. No, not inheritance. We'll have a attendance thread up for you. Have a good rest of your day. Goodbye.